In this video, we will solve this confidence interval problem. This problem, we will get Fcalc is less than Ftab. And so let's look at this problem. So we want to determine the concentration of X, an unknown compound. We have two sources, two locations. Source A gives us this data, and source B gives us this data. Source A, we took 4 measurements, and source B, we took 10 measurements. We want to know, are 0.025 and 0.037 significantly different from each other with 95% confidence? And so for problems like these where we have two sources, we want to first get Fcalc. So Fcalc is equal to standard deviation 1 squared divided by standard deviation 2 squared. And so intuitively, we would say that this is standard deviation 1 and this is standard deviation 2. Now this only works if standard deviation 1 is bigger than standard deviation 2. And so in our case, it is. So it's going to be 0.045 squared divided by 0.040 squared. And this would give us 1.27. Now this is an important note. Fcalc has to be greater than 1. Meaning, if this was 0.04 and this was 0.045, it wouldn't be 0.04 squared divided by 0.045 squared. What we would need to do is switch it. We would assume that this is standard deviation 1 and this is standard deviation 2. And that's an important note. And so once we determine Fcalc, the next step is to determine Ftable. So if the standard deviation 1, this one right here, we have number of measurements is 4. So the degree of freedom is 1 less. So it's 3. And this one right here, the second standard deviation, we have 10. 10 minus 1 is 9. So we had 9. Now in a table, if the standard deviation 1 is 3 and standard deviation 2 is 9, we would get Ftable would be 3.86. And because of that, Fcalc, which is 1.27, is less than Ftable. And because of this, the way we solve for this problem is a bit different had we had Fcalc greater than Ftable. And so let's do this. So there'll be two formulas that we will use whenever Fcalc is less than Ftable. First formula is Tcalc. And that's going to be equal to the absolute value of x1 minus absolute value of x2 divided by spooled times the square root of n1 times n2 divided by n1 plus n2. Next, the formula for spooled. Spooled would equal the square root of standard deviation 1 squared n1 minus 1 plus standard deviation 2 squared, parentheses, n2 minus 1, close parentheses, divided by n1 plus n2 minus 2. So this is an important note that in this step right here, we identify this term right here to be standard deviation 1 and this to be standard deviation 2 because Fcalc must be greater than 1. And so if this is standard deviation 1, this is average 1, and this is n1. And if this is standard deviation 2, this is average 2 and n2. And so now we will solve for spooled and then Tcalc. And so spooled is equal to the square root standard deviation 1 squared. So we have 0.045 squared, parentheses, n1, which is 4 minus 1, close parentheses, plus standard deviation 2, which is 0.040 squared, times n2, which is 10, minus 1, close parentheses. Now this will be divided by, so 4 plus 10 minus 2, and so we would get 0.0413. Next, we will calculate Tcalc. And that's going to equal, so average 1, which is 0.025 minus average 2, which is 0.037, absolute value divided by spooled, which is 0.0413, times the square root of n1 times n2. n1 we said was 4 times n2, which is 10, divided by 4 plus 10. And so we would get 0.49. This is the value for tcalc. The next step is to get the value of t-table. T-table is equal to n1 plus n2 minus 2. So 4 plus 10 minus 2, and we would get 12. 12 is our degree of freedom. 12 would correspond to, let's look up, and so 12 would correspond to 2.179. It's important that you simply don't add. You don't go 4 plus 10 and get this number. It's 4 plus 10 minus 2, and so we get 2.179 for t-table. So we got 2.179. Now for the final step. Tcalc is less than t-table, right? Tcalc is 0.49. T-table is 2.179. So tcalc is less than t-table. And because tcalc is less than t-table, the final conclusion is not significantly different for 95% confidence. Had tcalc been greater than t-table, it would be significantly different. And that's all we need to do for this problem.